Okay, good morning, everyone. Uh, I think we have done uh, the introduction of the parametric, also the tangent problems in parametric, and also some of the sketching graph review. If you remember, we did this in Calculus 1, but now we try to implement in the uh, the parametric equation. Okay. So I think one of the emphasis that I want to explain is about the second derivative. Okay, so the second derivative, okay, although it seems that if you see the pattern, it seems that we are having the first derivative like this, and then when we want to derive one more time, it seems that we are going to do this, right? But remember, we need to do this way, okay? And that's because of the functions relations, okay, between all the expressions. Okay, now I would like to continue. Okay, so we have done the tangent. Now another part that is crucial in calculus is the integral, or the area problem. Okay. Or we say here, this is the integration. So just a quick review on the integral. That is, if we have like a random curve like that, and then we are going to, let's say, evaluate from, let's say, 1 to, let's say, here is 8. This is y equal f of x. Now we would like to compute this area below the f of x. What we can do is the area will be the integral from 1 to 8 of f of x dx. Or maybe if you want to make it more general, let's say this is not 1/8, just a and b, to make it more general. Okay. Or you can also write as y dx, and y is f of x, okay, same thing. And now to implement the parametric equations, so if we let the x is f of t and y is g of t, and we know that we could relate that dy dx is, by the chain rule, this way, right? So the same way, when we apply into our equation here, if we could somehow change this y into, let's say, a function of t, like g of t, like here, okay? Or if we just write in general, okay, if we write just in general, we could write that the area it can be y of t and then dx, and then to make sure that we have the same variable with this t, then we need to take the chain rule and then multiply with dt, and then the interval will be from t1 t2. Okay. Or if you want to make it more consistent with the with our previous explanations, we can make within this one. Okay. We can also make a and then changing to t1, t2, and then g of t. Okay. And then the dx, we could write from this part here. So if we would like to dx f prime t, right? If we derive one time. So it means that our dx on the integrations also can be written as f prime t. Both cases are similar. Okay. Okay. So they are the same thing. So you could get into this one or that one. But the idea is your component of y is in function of t, and then your dx is the first derivative of the x of t, okay? And then adding dt. So you can have, so this one is, these two is similar, the same. Yeah, I think we can have one example. Also to review your calculus. So I have the graph of the cycloid. Okay, so we need to compute the area between this one cycle. Okay, so this is we call this is a cycloid, and I will give you the equations. So x is r theta minus sine theta, and then y is r1 minus cosine theta. So we have this cycloid, and then we have relations in terms of parametric with the parameter theta. So we are going to find the area. So find the area under one arc. One arc means there's only one loop, okay, of the cycloid. And every 2 pi r, it means that the distance is, so cycloid, okay, if you curious, so 2 pi r is one circle, the distance of one circle. So this is actually how to imagine the cycloid is like you have a road, and then you have a tire. Let's say you ride a bicycle. So this point that touch the bicycle, that one point, when we move, it also moves, right? So that point from this one here, let's say if I drew this one here, I have one circle like that. So if we move this one, the point on this origin also changed, right? So let's say I move to here. So let's say this point is here, and later the point may be changing to this one. Okay. Oh. So when we move this point P, I'll also move it. So the cycloid is actually the movement of this point P, and then it's moving like this. And why the distance 2 pi r? Because it's exactly from this point. All the points will be on the distance every time it's moving. So that's why it's 2 pi r. Okay. So that's cycloid. So if you want to find the area under only one arc, which means that we are only taking the interval from 0 to 2 pi r. So we could take this and write the area as from 0 to 2 pi r y dx, right? Okay, I will need to. So why we have the so we already have the equations, right? So we could exchange that. So we can exchange to r 1 minus cosine theta, and then dx we get from the first derivative of x So I think I will go here just to so dx dt, or now it's d theta, right? Since we derive with respect to theta, then r is just a constant. So let's write r, and then this will be 1 minus cosine theta. So dx is r 1 minus cos theta d theta. Okay, and we can exchange this dx into the integration here, right? So this will multiply with r 1 minus cos theta d theta. Okay. So I think we can make it squared, both of this expression, r squared and 1 minus cosine theta squared. And because r is a constant, I can take out r, right? So area, so r squared and this will be 1 minus cosine squared, cosine theta squared d theta. Okay. Now we can expand this. That has a quadratic equations. So 1 minus 2 cosine theta plus cosine squared theta. Okay. Now how to integrate? Anyone still remember? Okay, so whenever you find, every time you find sine squared or cosine squared or sine with power of 4 or many powers, the idea that you should have is you should remember the identity, one of the identity. Okay? So always taking this in your mind when you're taking the trigonometric, we write over here that this relations, I will write the whole formula. We can have the 1 minus 2 sine, right? Okay. Okay, so the idea is to exchange every square into the double angle. Okay? Because when we have this double angle, we can integrate easily, right? Okay. And I think this is in the whole calculus 1, calculus 2, this mostly appear like a small subject inside a bigger problem. So if you don't know how to do this, then you will not solve that problem. Okay? Because this is like only a small way to find integration of the trigonometric. Okay. So let's implement this into our equation here. I think I will move this to this side. Okay. So let me continue to write. So this will be r squared Oh, I forgot. Since this is x And now this is only 2 pi. Okay, 2 pi here. Only the parameter, because we make it the theta. Okay, the theta here. The theta is from 0 to 2 pi. Okay, I forgot to mention that. Okay, now back to the integration. So r squared 0 to pi okay, let me just complete the double angle formula. So 2 cosine theta, and then plus, if we look here, if we look on the side, so cos squared theta is half, right? Or we can take out the half, and then 1 plus cosine 2 theta. Okay, and then another bracket, and then d theta. Okay, so now we can compute the integrations. So 1 plus 1 over 2 is 3 over 2. So minus 2 cosine theta, and then plus half cosine 2 theta. Cosine integrate becomes sine. So this will be 3 over 2 theta minus 2 sine theta. And then what will happen with this? This will be sine 2 theta over 2, and then multiply by 2. It's over 4, right? And then evaluate from 0 to 2 pi. And if you find, because the 2 pi for sine, they are making it 0, so we can focus on the 3 over 2. So it will be 3, right? So it will be 3 pi. So 3 pi r squared. That is the total area. Okay. So every time, let me just make some emphasis. Every time you have this square on trigonometry, I think the best way to simplify the problem is to take into double angle formula. Because if you have this, it's not easy to integrate. The square of trigonometric form is not easy to integrate. Okay. Unless perhaps the secant squared, which can be integrated to tangent. Right. I think we can move on. So this will be the integral. And I think we can move and finish off the calculus in parametric. Okay, so we can go to what we call the arc length. So what is the arc length? So let's say we have another random function. Let's say we are focusing on just a normal graph. And naming the points is A and B. So arc length, if you remember correctly, the point from A to point B, we can measure the distance. We can measure its length. That's what we call the arc length. Okay. And now how to do the measurement easily? So if you forget the formula, or if I ask what is the arc length formula, you try to memorize, right?
Yeah.
But let me show you, if you forget, this is what you can do. Just draw any random curve. Let me zoom in a little bit. And take like some line here. And imagine this line like a tangent. Like a tangent. And then naming this as a DL. Okay. And then make a triangle out of this DL. Right triangle like that. Okay? And then make the name dx, dy. Usually if you see any d in the variable or in the symbol, it means that it's very small, right? It's very small in calculus. Okay, and then take the Pythagoras. I think Pythagoras you should know, right? Okay? Take the Pythagoras. Okay. So DL will be square root of okay. And now I want to normalize this too. Okay. Let me normalize that. And let's force the factorizations out of the dx. Okay. So I can make dx. So 1 plus, let's say this is dy squared. And I will force out to make this happen. Sorry. Too small. Let me make it bigger. Okay, I can make this. Okay. So dl is equal one plus, and then I factor out through the square root. Okay. And then we take the integral. Then that is the outline. Okay. If you forget, you can do this thing, and I think intuitively you will get the formula. Okay. Do not force yourself to memorize everything in calculus. So this is arc length with just a normal functions, okay? But now we want to convert this into parametric, okay? So in general, this is maybe x1, x2, because it's on x. Now for the parametric, the idea is still the same. We are starting from here. But now we are making dy and dx and adding another variable which we call dt. Okay. But let me wait. If you want to take the notes, okay, let me wait for a while. And let me continue the parametric on the left. So this is on parametric. Add t. Okay. So we can write that L is the integration of dl, and this is equal to integration of and I think if we finish chapter 10, I think not today, maybe next week, we will have a quiz. Okay? but we still have the polar and we haven't yet get into polar. Maybe today is a little bit introduction and finish next week. So maybe on let me check my calendar. I think on 13th, okay, Wednesday, that will be perhaps the first quiz. Okay, now 13. Let's 10. Yeah, 13 September. Okay, now we focus on the parametric. So what should we do now? We implement the chain rule as usual and adding the dt for both of this. So dy dt and then multiply with dt, and also the same thing with dx. So divide by dt and multiply dt. Okay, and then let's factor out this dt squared. Let's factor out, and then we can factor out from the square root also, so we could have dt, right? Let me write step by step. Okay, so we could have dy dt squared plus dx dt squared, and this is dt squared. Okay. And we could simplify it and write this is t1 t2 and take this y prime t squared plus, let's say, x prime, or if you would like to make it maybe f prime, maybe better. Same thing with the previous explanation that we have this relation, and then that's it. This is the arc length. So this is for x is g of t and y is f of t. And of course, assumptions that they can be computed. Okay, they can be calculated. It means that they are continuous, integrable. Okay. So this way or this method of proving is not real proof of the arc length, but somehow it's true, and we can use this method. I think it more easily rather than the definitive proof. Definitive proof is using the summation, the sigma. Like this one here, let me put this down. So actually, in this graph here, of course, it should be parametric, okay? And we can connect all this point along this curve and connect with the red line, which is our like a small distance. And the more you have point, this line will get close to the curve, right? Will get close to the curve. Okay? And that's how we plus and becomes the arc length. That's what we do. And that's why on this triangle here, what we have is I know that this is a little big in. If you see from the picture, it's a little big big, right? A little bit big. But if I make this having this d, it means that it's actually very, very small. So what we are doing is we take the integration of this dl. It means that we plus the dl from here and plus, and that's how we get the arc. Okay. Okay, I think. But if you want to proving like with the official proof on the calculus, then we can use the this definition using sigma and then later on with some of the theory we could write that this will be limit and of course they will have the similar square roots because they found the distance. They found the distance which is from the Pythagorean formula. Okay. And then by the definition of integral, we get the same conclusions. Okay, and then still in the arc length, we can also make the arc length as a function. So we call that as arc length functions. Okay, it's also in calculus 1, but let me just quick review what is the arc length function. So let me write here. Let's we using the new variable. So as let's say this is an arc length along the curve C from initial point. Let's say the initial point is f of alpha and g of alpha, it means the xy, to point f of t and g of t. It means that the point is on the variable, so it can be in any number. So we could make this as a function. So and still on the curve C, so we could write that St is from a constant alpha to a variable t, and this is a function with the form of the arc length. And since we take t here, the parametric inside, we need to use different symbols, okay, to make differentiation with the t. So let's use u. So this will be dx du, okay, squared plus dy du squared and then du. Essentially they are the same thing with the dt before, but since we make t as our end of interval of the integrations, we make new variable. Okay, I hope you get the point. So the idea of this arc length function is actually, if you have this like C like that, maybe we could take, let's say alpha is from here, maybe we could make it up until here, let's say that is t, and we can change this t. We can change the here. Okay. But anyway, we are not changing t into a constant, okay, because we want to make a function, okay, but with the arc length forms. Okay. And if you want to take the derivative, then this is like the calculus 1 fundamental theorem of calculus, then this will perfectly becomes dx dt squared plus This is the first derivative of s. Okay, now this arc length also usually we can connect to another components. In calculus, we can also measure the surface area. If you remember the surface area, so let me use the new page. Okay. Anyone still taking notes here? No, right? Oh, you're still taking, okay. Okay, now the surface area if you remember, let's say we have a random curve like this. Let's say this is f of x. Okay, now the surface area, remember if we have a curve like this, we can get the area from rotation of the curve with the x-axis, above x-axis, or y-axis, right? It will getting different shape, right? And also different, a little bit different formula. So if you rotate through the x-axis, okay, the surface area is integrations from 2 pi y. This is, let me write dl, this is the arc length. Okay, so this is the surface area. Okay, so this is if f of x rotated about x-axis. Okay, we will have a small break and we are going to continue. Okay, so as I mentioned, my plan is actually having the quiz on 13th of September, but that will be the only the parametric one, okay? Only the parametric, not whole chapter 10. But if you want to parametric and polar, maybe next 2 weeks we can have the quiz. So I think just the parametric is okay, right? Okay. So I can also prepare your TA to perhaps give you some exercise, okay? And I think I also give you maybe some like a homework, but not to be submitted, but just for your exercise, okay? Okay, now continue the surface area. So what we have here is if we rotate, so let me just draw what kind of shape that we have. So if we take this and rotate, it's like this, right? It's like a cup like that. So what we are going to find is actually the area around that cup, right? So that's practically the surface area. Okay, now let's, and what happens if we rotate about the y-axis? So if we see that, I think we can take over there, and it seems that it can be like this, right? And this will be the area of the surface area, right? Now what's the difference, okay, if we rotate about the y-axis? So if f of x rotated about y-axis, now the formulations will be integrations 2 pi, now it's x, and then dl. I don't think we can cover how we can get this formula, but I think you can just remember when you take rotation on the x-axis, like this one, then this will be 2 pi y dl. dl is the arc length. And if you take the rotations above y-axis, it's become 2 pi x dl. One way to remember which one is which is this one here. So this will be the distance from the origin axis is y, and the distance on this one is x. Okay. Now, what will happen if we take it into parametric? Okay. Or let me just write the formulations. So let me write here, just giving you notes. So suppose curve C by the same expression as we did from the beginning of the parametric equations, x and y as a function of t, and then let's say we have t1 until t2 as our interval, and all the g prime they are continuous, and then g of t is greater or equal 0. I forgot to mention this g of t. But let me just write here first. Okay. So curve C, we need to make sure that the curve C traverses exactly once as t increases from t1 to t2. Okay, so what does it mean is we need to make sure that we are not getting any loop, because if something if we travel the point twice, for example, then the calculation will be not correct. The arc length also the same. Okay, I forgot to mention. The curve needs to traverse only once. If not, then you measure twice of the length, right? Because you want. So, for example, if you have the like a loop like this, if you make it like, for example, traverse again and again, your calculation probably differ. Or maybe the easiest one to remember is just a circle, like for example, like circle like that. If you are not setting your interval correctly, you will make it maybe twice, three times, 4 times. Okay. Well, it's just a circle, right? Okay. So we need to make sure it's only traversed once. So let me write here, if C is rotated about x-axis, then area of resulting surface is equal as 2 pi y and this is basically just the arc length. Okay, this is the arc length. So what you need to take attention is it going to be y or x? So it depends on the rotation. So if rotated about y. So if rotated about y axis, then s and this is the same thing, the same arc length. So my suggestion to solve all the surface area, first is find the arc length. Find the arc length. Or maybe you need to find first which interval, or if the question already giving you interval, you can just find the arc length first. Okay. Find the equations and then simplify and then put here. Okay. Exchange this with the one that you already simplified, and then solve this integral. Okay. I think that's the most of the time that will work, okay, to help you solve the surface area. And I will give you some tips and tricks for solving this kind of situations. You see that we have the square, right? We have the square. So most of the time, this equation inside will be a perfect square that you can simplify using your algebra and then canceling out the square with the square root. Okay? Usually that kind of questions. So you need to find a way to cancel those two. If not, then you will stuck here and you will not be able to integrate. So there will be some algebra simplification first, usually. Okay, I will show you in the next page later. Okay. So I think another suggestion is usually like the questions, every mathematics questions, they will prepare some way to get to the really clean and smooth answer, right? So if you're given like questions, before you starting, just okay, we need to solve this, blah 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 blah. Just think first, and then if you like having some trouble, you need to take some time, and then maybe not to rush to solve everything faster, unless you are confident that you can do it. Okay. So sometimes the question has a trick for you, and you need to come up to discover the tricks. Okay. So don't be too naive when you see a question. I need to solve it fast. Blah, blah, blah. But you do. This question has a trick for me. I need to do something about that. And usually, because calculus will include algebra, you need to be familiar with the algebra. And how to be familiar is how we can identify what is the trick. Okay. So let me give you some of that on the example here. So example is, let's say we need to find surface area obtained by rotating the given curve about x-axis. Okay, we start with, this is the curve. Parametric curve, like that. And then we are given the interval. So from 1 to 3 for the parameter t. Okay, let me give you some times, maybe 4 or 5 minutes to try this one. So the keywords here, surface area, and then rotate about the x-axis. So you need to remember what kind of the form that we need to take, okay, if we rotate about x-axis. Is it 2 pi y, 2 pi x? Okay, that's your choice. And then after that, we have these equations. What we need to do first, perhaps taking the DL, okay, the outline forms, and then simplify, and then put into the integration. Okay. Let me give you a couple minutes. Of course, we need to take the first derivative first, right? Take the first derivative with respect to t. So we find the x prime and y prime. I think we can get easily. Okay, that's okay if you feel like when you have the square root, something big inside. That's pretty normal. But what I want to show you is you need to think from the small pieces from the big problem. So if we take the surface area, let me show you the surface area. We rotate about x-axis, which means that we are going to have 2 pi y, right? And then we have this long and this is from 1 to 3 dt. Okay. Now, sometimes if we are maybe like a young children, okay, it just goes in and then take everything, right? But if we take closely, maybe we can do something about this first before we try to force the integrations. Okay? If we are trying to like from the left and try to solve it, maybe we will have some difficulty, and sometimes it will take a longer time, right? So let's just focus on, let's take the dy dt, okay? Let's take it. What will be the derivative of 8 square of t? Okay, the easiest way, if you see any square root, okay, if you have any square root, for example, square root of x, if you take the first derivative, this will always be like this. Okay, so this 8 will become 4 divided by this square root of t, right? So let's write that 4, different color, sorry. So 4 divided with that. And then dx dt, 4t plus, we have 1 over t. 1 over t, if you differentiate, it will be minus 1 over t squared. Okay? How? We can take t as t with power of minus 1, okay? And take t dx. And then we take minus t and minus 1, minus 2. So this will be minus 1 over t squared, okay? And what we are going to do, we take the squared, take the squared, take the squared, okay. And what will we have here? Maybe let's move this a little bit down so it's having more space. So 4 is 16 over t, okay? And this one, we take the expansion of the quadratic, 60t squared, okay? And then minus 2 by 4 is 8 over t, right? Plus 1 over t with power of 4, okay? So, and then what we are going to do, what we do is we plus this, right? We plus this. 16 over t, we can plus with this one. So 16 over t minus 8 over t, it will be 8 plus 8, right? Plus 8 over t. So 16t squared minus 8 plus 8 over t, and then plus 1 over t with power of 4. And this is the one that will be inside the square root, right? As I mentioned, most of the time, and I think almost every question with the surface area and having the arc length, this inside expression usually can be cancelled out. So if you have a quadratic equations, this could be a perfect square, which means that you can factor it, okay? So how to factor it? So we need to think two expressions here. We have 16t here. We have 1 over t with power 4. So this is a little bit trial and error, but somehow it will be taken out quickly. So let's say 1 over t with power of 4. Let's say we try 1 over t squared. Okay? We take 1 over t squared. And the other way is 16t squared. So let's say we take 4t. Okay? And then we think, okay, if we multiply this, then we have 4 over t multiplied by 2 is 8 over t. It's the same, so we need plus, right? Okay? So we could take this. So when we are going to square root of this, then we get perfectly simplified equations. So this is okay. So we get this is 4t plus 1 over t squared. And now this will help you to integrate in more convenient way, right? So if we take a look here, then we are going to take this as from 1 to 3, 2 pi. Now y is the 8 with the square root of t, right? And then that will be just 4t plus 1 over t squared. Okay? So you will get 16 pi. And then let me write square root of t as a t with power of half. So then this t with power of half, if we multiply with t, it will just plus 1, so 3 over 2. And then if we multiply with t negative 2, we can also compute the power. It's negative 3 over 2, right? So this will be 4, let me wait with a bracket, t 3 over 2 plus t negative 3 over 2 and dt. And I think we can integrate this, right? So 16 pi. Okay, 3 over 2 integrate, so plus, so it will be 5 over 2. And we need to multiply 4 with 2 over 5, right? So let me write, this is 2 over 5. This is 4t, and then this will be 5 over 2, just to make sure that we are on the right track. And then plus, and it becomes I think becomes minus, right? It becomes minus. So plus 1 is, it will be 1 over 2, right? 1 over 2. So we need to multiply with 2, and then t, and then this will be negative 1 over 2, okay? And then plug in 1, 2, 3. There will be some computations here, but I think for my exam, you can bring your calculator just to compute something like that. But if you want just to compute just as it is, I think sometimes it's still okay. So it will be 16 pi 8 over 5t and then plug in the 3 and 1. You can take your calculator. If you want, this will be 15 pi. Or if you want to be in decimals, you can also compute. But if you stop here. It should be fine. Should be okay. Okay. Any questions?
Isn't that 16 pi not 6?
Okay, good. Please, you focus to listen. I did my mistake, sorry. Okay, yeah. So most of the case, this will happen. So you need to be curious on how to cancel out the square root. Okay? And if you are not really familiar with like the algebra, I think you need to take some time to have more practice, because the calculus part is the integrations part, right? Not this one. This one is part of like only the algebra part. Okay. Now after this, I would like to just give you just an intro on the polar, just a small part intro of polar, and we can end our lecture for today's class. Or I think we can have one more exercise. Okay? I think that would be better. Maybe just review from the tangent. Okay? From the tangent. Find tangent line equation. So x is et sine pi t at t equals 0. You can try for a couple of minutes, and let me show you how it's done. So remember, whenever you are asked about tangent, it's asking about the slope. Okay? It's asking about the first derivative. It's asking about dy over dx. But now we have the parametric. We have the t, right, inside the x and y, okay, in the functions. Okay, remember that you need to first find dy over dx, right? Let me just write that for you. And dy over dx is this. Okay, but do you remember how to do it? I mean the derivatives. Okay. So we have e power of t and sine pi t for x. For y, we have e to the power of 2t. Okay. Let me give you a couple of minutes to try. Okay. Actually, after this, I'm preparing some post tests, but I hope the time is sufficient. Yeah, I think time's okay. Okay, I think we can take the dy over dt as we have e with power of 2t, which means that we take the chain rule, so 2e with power of 2t, right? And for the dx dt, we get the product rule, okay? So we have e with power of t, and then sine pi t, the same, and then plus, again same e with power of t, and then the derivative of sine pi t is pi cosine pi t, and then we can simplify this. Okay, now we can take that into our dy over dx. Oh, wait. This is wrong here. Should be that. This is the x dt and 2e 2t. Okay, we can see that when t is equal 0, so when t equals 0, x is 0, right? And y will be 1. We can plug into the original equation for t equals 0. So that means dy dx when t equals 0 is, this will be 2. So this will be 1, this will be 0, 0. So this will be 2 over pi. So 0, and then this will be 1 cosine pi. Cosine 0, sorry, it's 1, so 2 over pi. So the equation, the tangent line equation. So remember that the dy over dx, this is the m. Okay. So we can write y minus y1 m x. Okay. The numbers is 0, 1. Okay. So tangent line equation at 0, 1. Right. So y minus 1, 2 over pi x minus 0, or y is 2 over pi x plus 1. Okay. So that's the tangent line equations. Okay, next will be the post test. I will prepare some questions from here, and what you need to do is just try to log in. Let me put the website, but if you're still writing the notes, I'm waiting first, because it's not the same with the last time. The Mentimeter, I'm trying another one. I think it's better. Okay. I think I forgot 3 or 4 questions, but like it's really short questions. I think only one question that you need to calculate. Two questions. Okay, but let's see. If the time is too short, okay, then it's okay. That's just my feedback. Okay, let's try. Okay. Okay, you are going to get into the website. Please join myquiz.com without space, joinmyquiz.com, and then enter the game code. Use your student ID as your name, okay? Do not use your name, but use your student ID so that I can easily pinpoint which one of you. Okay? If you have any difficulty to log in, let me know. Okay. Okay, I think few more students. Who hasn't joined? Okay, 13. Anyone want to join again before I start? Who is okay? 14. Anyone having difficulty getting in? Okay. Yeah, 15. Okay, let me know if you have difficulty. Okay. So everyone ready, Jay? Okay, I will start now. Yeah, 4 questions. Actually, just are you ready? Just answer yes. Answer yes. That's a point. That's a point. Okay, this is just a. Okay. Around 3 minutes. Around 3 minutes. So find the idea. So derivative, and then make it to rational. And find the correct one. I don't think you need to do some. I think you need to a little bit simplification. You choose the correct one. Okay. Okay. Next question. Let's see. You can make it. Okay. 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 It's false. Okay, it's false. Okay, last question. It will be a little bit using calculation. The same way we did in the exercise just before the test. since if you need to write the equation, pretty difficult to make in this quiz. So I'm focused on the coefficient, the constant. So do the same thing as we did before. Okay. Plug in the t for the dy over dx, and that will be your slope. Oh, I think I give you more than 4 minutes, almost 5, so it should be okay. Okay, 3 minutes left. So you need to write some numbers, right? But you need to make it into the y mx plus c, the forms. Okay, 2 students finished. Well, of course, it's in the exam, at least the time should be for this type of questions. I will give you at least 10 to 15 minutes. Okay, around 2 minutes. Yeah. How to get the x and y? Use the t. In an xy equation. Okay, around 80 seconds. So this is also a typical problem, like in some exams. So if you're familiar with this, I think for the chapter 10 you should be able to work on the in some parts of the exam. Aside from this is the integral and the arc length for the surface area. But most of the time it's the tangent, the integral, and the arc length. That is the most frequent typical questions. Okay, 5 seconds. Just I think you can randomly answer. Okay, very good, very good. Okay, it's 64. So that's it. Thank you for joining the test. This is also for your attendance. So see you next week. See you next week. Okay. And preparing for the first quiz. Okay.